This week, we speak with Brad Geesaman from Darkbit. In the news segment, we continue a case study on that conferencing tool everyone's concerned about. We turn to an interesting flaw in Slack, better bot barriers, a book on building secure systems, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/synopsys to learn more. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Welcome to Application Security Weekly. This is episode 103, recorded April 13th, 2020. I'm your host, Mike Shima. I'm here with Matt Alderman. Hey, Matt.
Happy Monday, day after Easter, snowing in Colorado. How's that work?
Happy Monday to you. Yeah, that sounds great. And we've also got John Kinsella. So how are things going over on your end, John?
Hey there, everyone. It's still quiet here. People are social distancing. I think hopefully we're over the curve, at least around here. Yeah, no snow. It's starting to warm up in Seattle, so that's a good thing for us.
A good thing. I'm sure you still have some rain coming up anyway. It is Seattle after all.
Yeah.
We have officially migrated our mailing list back to our original platform. We apologize for any double mailings or lack of mailings that you may have received in the interim. We have our categories nailed down, and you are now able to customize what you receive from us based on your preferences by visiting securityweekly.com/subscribe and clicking the button to join the list. Once you have joined, you will also be able to go back and update your interests so that we can grow with you as you progress through your journey in InfoSec. Is your open source code secure? Learn how to verify your code during development, not after the build, in our next webcast with Synopsys. Register for our upcoming webcasts or virtual trainings by visiting securityweekly.com/webcasts. You can also access our on-demand library of previously recorded webcasts and trainings by visiting securityweekly.com/on-demand. Each webcast will earn you 1 CPE credit that we will submit on your behalf if you provide your ISC squared number. Brad Geesaman is a co-founder of Darkbit.io, helping clients improve the security of their Kubernetes clusters in cloud-native environments. When he's not educating others on the security risks inherent in complex distributed systems, he enjoys spending time with his family in Virginia, eating Mexican food, and collecting an impractical amount of ebooks. Hello, Brad. Thank you for joining us.
Thanks for having me.
I don't know if you listened last week, but in last week's news segment, we talked about Microsoft's effort to map the MITRE attack framework onto Kubernetes. And so that was one step towards understanding how clusters and pods are targeted and compromised. But I thought it'd be interesting to take that discussion a bit further. And how could we start making Kubernetes clusters a completely hostile place for attackers? And where should we even start in that conversation?
Yeah, there's a lot of bells and whistles and knobs, and I think for a cluster to start with, it takes several layers, and typically different teams that run each layer, and so it takes a lot of coordination. But there's a lot of things that you can get kind of bogged down with, and if you sort of pivot and look at it from the perspective of, I just want to defend against external attackers and think threat modeling from their perspective, there's I don't want to say a handful, but there's several categories of things that if you are really keying in on those things, you can make the life of an external attacker very difficult inside of a Kubernetes cluster. And so, things like restricting the control plane access and SSH access, so the administrative access to the clusters, is number one. And I think it's often overlooked because cloud providers tend to allow that by default. But that's one of the first things that you can do to substantially reduce attack surface externally. But then also standard AppSec. So any app that you're running inside of a container that you're maybe exposing to the internet, that's still a web app that still has vulnerabilities. You still have to take that very seriously. But that's really sort of the traditional external pen testing focus. Those things you have to cover, right? But then there's a couple other things that you have to do that sort of assume breach, right? So if you just take it one step further and say, what can an attacker do if they got access to this specific pod? If you just ask that question of yourself for every single pod that seems critical or is externally exposed, say, if I had a shell on this pod, what damage could I do? What access could I have? What tokens, credentials do I have access to, and what could I do with those? I think that fits, part and parcel with the cloud attack framework, the Kubernetes variant that I did see last week. I was very excited to see that because I don't know if you noticed, but if you look at the attack framework, there's tons of things, and you're like, wow, that's just a Byzantine mapping. But if you look at the cloud and specifically the Kubernetes variations, it's actually a reasonable set of things. It's 6 or 7 max in each one of the categories of the techniques. And so, when you look at it, there's only so many things you can do right out of the box that are very clear and straightforward. And so if you take some of that assume breach mentality and say, all right, if I have a shell on a pod, what are the 2 or 3 things that I should do to make sure they can't laterally move or privilege escalate or hit the metadata of the cloud services? We're just talking about basic things like network policy, an often misunderstood and underutilized tool, but by default in Kubernetes, pods can talk to each other. All pods, no matter what namespace they're in, can talk to each other. And that's not ideal. You have a front end web app that's externally exposed. It has no business talking to your monitoring system or hitting another database from another workload that's not even attached to it. But by default, you can. So if you think about network policy as putting firewall rules around the pod's virtual interface, think from that perspective. That like assume breach where you're sitting on the pod and you have a shell on it. Like what could you curl? What could you nmap? What could you scan? And if you just say, well, it's only the app it's supposed to talk to, that's such a dramatic surface area reduction. And the second thing you can do is say, are there any credentials, specifically service accounts inside of Kubernetes that are mapped inside that pod? Do those have any permissions? And if not, great. If they do, are they the least possible that pod needs? That's the second thing. And the third thing is sourcing your images. So Ian Coldwater and I like to joke that you're running other people's code as root on your compute, and that's what Kubernetes really is. And that's sort of a mocking take on images come from everywhere, and images are libraries and applications and binaries that you're just inherently trusting. If you take those and look at every single image that you're running in your cluster, and you know where they're coming from, and they're not just coming from somebody's Docker hub, some random person who made that image, and that's not what you're bringing in, you're vetting it. Knowing where your images come from dramatically reduces the possibility that somebody was covertly or mistakenly injecting code that shouldn't be in your cluster. So if you're vetting images and you know where all your images are coming from, and you're restricting those images to only come from the registries that you approve, that's a huge reduction in attack surface as well. Because when you get into a cluster, typically you're on a pod that doesn't have the tools you need. And if you have the ability, it's really handy to pull in your own container with all your attack tools. So if the cluster doesn't allow that, that makes it that much harder, and that makes the attacker work that much harder and generate more egress noise, right? So instead of using the built-in mechanisms, they're having to pull their tools in manually and figure things out that way. So they can't just run ready-made things. Go ahead.
No, I was going to say, well, maybe you've got one last thing, so we'll keep people on the hook and in suspense for what one last thing will be, because you've already run through 3 that I think are pretty fantastic. And that point you were making too, making it harder for attackers to live, or requiring them to live off the land, so to speak, rather than pulling in their own tools, is a great mentality. And even when you were talking about, I liked how you dove in right from the beginning of assume breach and what can we do to contain and reduce what the overall impact is going to be. You were talking about restricting lateral movement, and you were kind of hinting that the name spacing isn't really a strong boundary. And in the world of pods, and even honestly in the world of cloud, IP address based firewalling really isn't reliable either. Or if you're going to try it, it's going to be horribly complex. So what's a better way then to not have to worry about IPs and to dive in and creating better network boundaries in this type of scenario?
Yeah, like you said, namespaces are not a boundary per se. They're just a way of categorizing resources in a group, right? But why they're important in Kubernetes is because a lot of the security policy and configuration you can hook onto namespaces as the starting point of the grouping. So network policies in Kubernetes allow you to do standard CIDR if you want to, but that tends to be brittle, like you mentioned, right? You want it to be flexible. You don't want to have to care about a specific IP address. You just want to say this app in this namespace can talk to that service in that namespace. And so labeling becomes very important. And so network policies can take advantage of the labels you put on workloads. So I could say app front end talks to app back end, and that literally are the labels that you put on each one of those pods, and you can make a network policy that says that is allowed to talk to that on this port. And just by doing that, you make a more flexible and not as brittle network policy that protects those apps. Even if you move them around or change them as far as naming, as long as you don't change the label, that policy still applies exactly the same way. So you could put, build IDs in your name, and it doesn't matter. It's just what it's labeled can talk to that other thing is what it's labeled. And that's, I think, what's important to understand is namespaces as a grouping mechanism are the foundation for your security policy approach. If you put everything in one namespace, it becomes very hard to tease things apart and keep things separate. But if you have these three apps that need to talk to each other, you put them in their own namespace. If you have these apps that should never talk to these others, definitely separate them into different namespaces. But by default, there's very little, boundary that's given by default, like in that default state.
Brad, in the early days of containerization, we saw a lot of technologies try to take some old school approaches like network security and microsegmentation, some other things, and tried to implement them into the space. I think Kubernetes has created some very interesting ways to approach this natively without requiring some of these external kind of tools, but it requires a really good layout of how you want to design and kind of segment pods, apply appropriate rules or configurations to them, and then obviously doing things like stop giving up root access to a lot of these devices. I mean, is that where you see Kubernetes really providing more native capabilities, if done right, than necessarily requiring a bunch of these external tools to do it?
Absolutely. I think so. All the core capabilities are there, and you're right. Your approach needs to be strategic and systematic. It can't be ad hoc, or you're just going to, just do pockets of good things here and there. Where I think it gets a little tricky is if you have partial or incomplete implementation of that strategy, and you're trying to add things later or bolt things on. That's where the policy gets tricky. And teasing out what application ports from this service to this service that need to be allowed is difficult if sometimes the things that you're provisioning aren't things that you wrote yourself. So for example, an operator will deploy these 3 pods in this namespace and it expects to be able to talk to these other things. And if you're doing the right things by putting a default deny network policy in each namespace, you have to systematically add the allow policies to let that work. Sometimes it's really hard to troubleshoot that and figure that out for those things that maybe you don't control. And honestly, sometimes developers who don't know what their app is actually doing, they just go, yes, it talks to the database. You're like, well, what port? I don't know. And you have to sort of figure that out. But once you figure that out, it's sort of a one-time thing. Like that application doesn't necessarily, change its ports that it talks to the database on. It's a one-time upfront effort. But if you do it consistently, that attack surface is greatly reduced. And I think the external tooling is just trying to help make sense of things and try to tease out those network policies without having to do it manually. And I think that's where some of the value is on those, if you choose to go down that route. I know that I think Monzo was doing some very, very interesting things at like 1,200 microservices at scale, automatically defining network policy and implementing those things. It really speaks to all the capabilities are there, and you can do that, and you can go crazy and customize anything that you really want. It just takes sort of a scale first approach. The old manual firewall rule change ticket approach is really going to be difficult to implement in a Kubernetes cluster. I come from the firewall background, the layer 4 back in the early 2000s kind of thing, and just how that works and how firewall rule changes come in and be pushed at 2 a.m. That you just cannot go with that approach inside Kubernetes.
I hope I never do, but at the same time, I'd really love to see someone try to do trouble tickets for firewall rules on Kubernetes. But Brad, I want to take a step back. And this is sort of one of the things I absolutely drives me nuts if I go into a talk at a conference or someone. They start off and they start telling me definition of the cloud. So I don't want to go that far back. But if someone just came into this podcast and they had listened to ASW before, I think they probably understood 5 words. So, and the reason I'm setting it up like that is what I want to sort of talk about for a second, or see what your thoughts are, is you're talking about all the right things. But how does someone who is, they know this Kubernetes thing is out there, you're getting closest for a little when you start talking about design of implementation. Do you have best practices or recommendations? Because this thing is, it's so configurable, so big, such a beast. How do you recommend someone start drinking from that lovely fire hose?
Actually, one quick clarification. When is the right time?
Yeah.
So Paul and I have had this conversation internally for our application.
Mm-hmm.
We don't think it's big enough to require us to go to Kubernetes, right? And I think the other question, Brad, is when does Kubernetes make sense and when does it not make sense also?
Yes. So you'll get varying opinions on that. Mine is sort of like, I come from the early infrastructure as code world, where it's like you have a couple VMs behind a load balancer, maybe you CloudFormation or Terraform that. I think once you get 3 to 5 that are literally following the same cookie cutter pattern, you have a load balancer, you have an instance group, you have the same VM, and you're doing the same thing, and maybe you're starting to containerize your application already. That started when it starts to make sense to have consolidation, because realistically it is complex. There's a lot more overhead, but it only makes sense at some tipping point of scale of several applications that are identical in methodology and deployment and containerization and security needs, that kind of stepping into the Kubernetes world makes sense. If you're going to do it for a hobby project to learn, great. That's fantastic. There's low cost clusters on any cloud provider. But from an organizational perspective, you have to sort of be committed to containerizing and saying, this is how we're going to deploy by default. Otherwise, we're going to do something special, but this is our main way to do it. We're going to use pipelines, we're going to build images, and we're going to repeat this pattern, and we're going to take advantage of the repetition of this pattern. If you have teams that are doing something very, very specific and custom, and that's your whole business model, maybe Kubernetes isn't right for you right now. Maybe it doesn't have those features natively, and you're kind of going against the grain with it. But if you're doing web apps and microservices, and you're solving all those same problems over and over and over again, you sort of have to hit that pain before you realize, we can make the efficiency gains with running all that through the standard API that Kubernetes offers. And then you're taking advantage of scale and efficiency and auto scaling and things like that.
We're diving into this and figuring out, when to use Kubernetes at what point, there's also, even like Matt had mentioned, if done right, and you've been mentioning a lot of times, there's a lot of effort to set up network policies. How much of this does just the secure or insecure, perhaps, defaults of Kubernetes, how much of that is working against DevOps teams? And how much of it do you think just a couple changes in Kubernetes, the project itself, by changing the defaults, could help with everyone be more secure?
Yeah, that's the debate, right? The security-minded folks are saying these defaults are causing us pain, right? If we could
Hmm.
fix these upstream, we have a ton less things to fix downstream or worry about downstream. But it's also the culture that it instills. It's Kubernetes won the container orchestration race partly because it ran really quickly. So features were prioritized and incentivized. Okay, and so the defaults are made such that it's easy, it works out of the box, and you're not fighting up against default policies that block you or inhibit a deployment from working out of the gate. Because honestly, the first time you run Kubernetes and you deploy pods, it's tricky to get a service and a deployment and a container and an image, get them all plumbed together if you're doing it by hand. And once you understand it, it makes sense. But that's a lot of cognitive load. So the sheer complexity of Kubernetes puts a ton of cognitive load both on the administrator and the developer. And so anything that's security in there that's automatically disabled by default or denied by default gets in the way of that and prevents their flow. And so a lot of the incentivization from cloud providers is to get you going and to get cloud spend, right? They want you to run your app seamlessly. And I think that's sort of at odds with what we're dealing with. So every time that you go to a Kubernetes talk and you hear it's insecure by default. Well, it is, but most of the time it has all the knobs that you can really need to do some really good stuff to lock it down and make it a real pain in the butt for attackers. It just takes effort. And so when you have two or three of those, it's not so bad. But when literally everything that you're deploying requires some lens, some look at it and go, do I like that default? Do I like that default? It requires that focus. And that's where I think it works against us, because there's not enough security minded folks that are taking a look at this in every organization that are deploying Kubernetes. And they're not looking at it from that perspective of, holy cow, if that pod was compromised, this is completely terrible. Let's go back and find the default, fix the default, and we'll just never do it incorrectly again in the pipeline. That takes speaking DevOps, that takes speaking to how the deployments are done to know how to tease out the origin and the source. And I think there's part education, there's part incentivization, there's part inertia. Defaults that are set tend to stay defaults that are set in production. So you get a cluster working in dev and there's so many moving parts. Once you sort of get it working, you just want to take that and put that in prod. That's the natural instinct. So I think there's several things that are working against it. But we've done crazy things like run capture the flag exercises at scale across multiple regions in AWS, across multiple clusters, and having people attacking workloads inside Kubernetes in the 1.4 days. That's been 3 years now. There are ways of doing it. I don't recommend that, but you can. If you don't really care about that cloud account and you keep it really contained, you can do some really cool things. And that's what's so interesting and powerful about Kubernetes is if you do take the time and you do turn on all the levers, you can do some very, very interesting things. So that's sort of like the other side of it. You can go to that length. It just takes some effort.
Is that where the commercial tools, because we see a lot of people focusing on Kubernetes security now, is that where some of these commercial tools come in and potentially help with a lot of these defaults that we know are not secure, but because it's so complex, there's so many knobs and buttons to turn, are there good commercial tools out there that are making it easier to implement the right configurations in Kubernetes?
It's really, really difficult. There's a couple things. The release cadence, so another thing I didn't mention that pushes this to the the 90 miles an hour speed rate. It's every 90 days roughly there's a minor release, and so it's really, really hard for vendors and tooling to both stay ahead of features that might get baked into upstream and add value there, and it's also really hard to keep releases in that same cadence and keep it working with the latest and greatest. And I see some tools that are promising that can really help with some of those individual aspects, but it's ultimately they're often solving for or making up for some of the defaults that maybe if you went back and did change some of your assumptions when you made your cluster or built your cluster, you might not need as much or need not to rely heavily on some of those tools. But then there are other tools that Kubernetes just literally does not do. They don't do container behavior monitoring. So if you have a Aqua, Palo Alto, Twistlock, or Sysdig, or anything like that that's installed, those add value that Kubernetes doesn't necessarily have, right? For example, I'm not endorsing any of those specifically, but those are some of the big names, and they're making an impact in that perspective. But any tools that tend to improve or enhance upon the defaults, add a little bit of nicety tend to have a little bit of trouble, because if you do apply the elbow grease, you can get pretty far along in that perspective, and then you're solving that problem yourself once and done.
Interesting, because like I said, I've seen a lot of these, and John and I come from the container security space. I always felt if you could do it within the container running in user space, you probably had a little better control and protection than relying on the orchestrator, especially with the complexity of something like a Kubernetes, right? But then you see all these new players going after the Kubernetes configuration, and the question is, can they really make a dent? It sounds like they're not quite there yet.
I think there's sort of a culture of Kubernetes, right? Like the early folks that embraced it were the ones that were taking binaries and putting certs next to it and running it, and they were getting the benefit out of learning from that early. They understood how everything worked under the hood, right? And they're able to scale that and go a million miles an hour, and that's really where the power is. And I think if you come along and say, all right, you're going to go with this free open source software culture, and you layer over top of that some, a vendor's product that maybe doesn't run at your release cadence, it can really be a challenge sometimes if they don't support the feature or the release that you need. And sort of the taking it in-house helps keep you going at the speed that you want and keep you giving that business edge. So maybe you're a SaaS offering and you're able to offer things that are $1 or so cheaper per month because you're able to run more efficiently. Anything that you put into your Kubernetes cluster that doesn't run at your release cadence and doesn't run as fast as you do could help, could pull you back as a business. So I think sort of the build it yourself, learn how to do it, and learn how everything works as part of the original culture is where there's sort of a clash where traditional security vendors come in and want to lay on top some policy engine, and as opposed to building the policy in, they want to layer the policy on the top at the end, and it kind of conflicts with the feedback loops. So developers might get blocked and not have an understanding why, as opposed to going back to where the developers are and saying, no, run this check before you commit, and then you don't have to worry about this ever getting blocked again because we'll check it in the cluster. The developer's not surprised later on. And I think there's some, like I said, culture clashes with where vendors play and where they put their policy and how they enforce, that goes against some of the original tenets of moving fast and shipping fast and failing fast and fixing fast that DevOps culture pushes with pipelines.
And I think from some of the customers we saw over the last few years, big box stores coming to mind, but for an org that, as you're saying, Brad, actually they have the experience and the capability that they know those tools inside out. They know what bells and what knobs need to be tweaked. Mm-hmm. That's awesome. But it comes back to my question before: the folks who are sort of stumbling into this space, yes, that are like, they've heard about Kubernetes. How do they get up to speed on that stuff? I mean, I'm not trying. I'm not a vendor anymore, so I'm not here to try and justify my existence. But at the same time, I think for a lot of those folks, being able to just click a button or as valid or not it is, be able to trust the tool. I think for a lot of folks, they like that ease. So how do they get up to speed in figuring out, all these things that they need to adjust in Kubernetes to go the direction you're thinking?
Yeah, there are a lot of tutorial resources out there. Learn K8s, Kata containers, Kata Coda. That's a mixing of terms. Kata Coda. There's a lot of books that are doing a very good job now of catching up and helping that introductory level as things mature. But you're right, it's a deficit. Like there's a lot of things to be thinking about. It's hard to keep up with the ecosystem as it is, with its explosion of the CNCF landscape, just thousands of vendors and projects. Which ones do you pick? How do you know which ones you need next? It's very challenging. And I think that's part of Kubernetes maturity that needs to grow very quickly, or it risks sort of what I feel is a complexity, an aversion to complexity. And it's hitting a complexity point where people are actually pushing away from it and saying no Kubernetes because it's just too much. It's too much to catch on at this point later in the stages of its releases. Like early on, there were only 6 or 7 things you could do inside of Kubernetes. Now there's hundreds or infinite because of custom resource definitions. You could extend it in any way you want. The cognitive load has gone up so high that it's really, really hard. I empathize. It's really hard for someone new coming along. So it's a trade-off, and I think it's one of those things where the organization has to look at it from cost and complexity. Building it yourself is definitely not recommended these days. Leverage platforms that help you with that. Sometimes cloud providers can do that really well for you, but don't try to rebuild it from the ground up and run Kubernetes by yourself unless you really, really understand the benefits, and that's a cost-benefit thing. So I don't have a great answer, honestly. It's the resources that are out there are improving. They're really getting you up to speed, but it doesn't necessarily cover the ins and outs of everything that you need to secure and harden, because there's just so many and they change weekly. So when a feature comes along from an open source project that adds 3 or 4 more knobs, you have to keep up on those to know if those are things that you want to internalize inside your organization. And that's a lot of effort, honestly.
I guess what you're really trying to say is they need to go to darkbit.io.
Sure. We could certainly help with that. I'm sort of stepping back because it's a love of mine. I've worked with Kubernetes for so long, and I really see its power. I've seen it do some really crazy and amazing things. I've seen it, do 10,000 GPUs in a cluster and just crunching on AI. And you're just like, that's amazing. And then you see it run a small web app, and you could do it really efficiently with a couple nodes for a couple dollars a day. And you're like, this thing can do anything. And that's also its Achilles heel. It can do anything, and its defaults can let you do anything. And it's up to you to say, is it doing the right thing for me? And knowing how all of those configuration options interplay is that's the challenge. So I see the benefits. I see what it can do and all the fun things it can do at huge scale for low costs if you do it correctly. But then I also see, what happens if you just go with the defaults and, let that security posture be what it is. One of the things that's actually surprising to me is that we haven't heard about, or at least publicly, I'm sure it's happening, but we haven't had a lot of public incidents that are well described inside these environments. I know Kubernetes adoption is, quote, exploding. I know it's a small percentage of the overall IT spend, but we haven't heard or seen a lot of these tangible, this is exactly what they did, here's why. But I can envision if there was an application vulnerability in a web-facing container, I can envision some horrific things happening if it hits the right cluster, because most of the internal security posture of a cluster tends to be default. It tends to be wide open. It tends to have overly permissive access. And so that's sort of what I'm sort of hoping doesn't happen, because the opportunity is there. It's probably just a matter of time.
So last summer, I think it was last summer, there was Trail of Bits and Atreides Partners did a audit of Kubernetes, which was really cool, really informative too, just from a learning experience of the ins and outs of Kubernetes. And I think that kind of sort of alludes to, or gets to what you were alluding to there. My question is, you mentioned before about being able to dive in and changing those insecure defaults, so so that it's less of a joke as an intro in every single conference presentation. Are there some other areas that you would call out, or some additional things that you would highlight to call to action, if you will, for the community to do around Kubernetes?
Yeah, that's a good point. The audit that was done was, a huge effort, and Jay and Aaron and others, and I'm missing names here, did a wonderful job of getting that ball rolling. And I think what's really important to do, that's a point in time audit, and it had some scoping, narrowing that was done for the sake of, because it's such a big project, millions of lines of code. I thought they did a very nice job threat modeling Kubernetes and sort of giving the industry hey, you might want to look in these areas. We didn't have a chance to cover literally everything in here, but these are some areas that seem interesting. And that was great at the time it was done. My thoughts are, though, that maybe this is something that we get into a routine cadence. Maybe the CNCF or the Linux Foundation says this is something we should do as a community. We all fund this, and we do this on a routine basis. Maybe it's every minor release. That's me hoping. But maybe it's twice annually, something like that, that continually takes advantage of the new features that are released, and are continuously auditing and assessing those. Because if you look at the change log for every single minor release of Kubernetes, there's hundreds of features that are added or fixed, or behavior that's changed. And that means, code is moving very quickly, and that means attack surface is either developing or going away. very quickly. Hopefully it's going away. But that's something that I would like to see. I would like to see this as a regular routine cadence, and maybe even parting out pieces to folks with different specialties, because it's a lot for one or two small organizations to take on themselves and really try to get full coverage. Because I think that would go a long way to sort of formalizing the process of assessing the risk inside the code base and looking at things that are fast moving and prioritizing security, eyes and code improvements in those areas for things that might potentially head off whole classes of attacks before they happen.
No, and I think and probably too, we've been describing is a lot of effort for what DevOps teams need to do to figure out, do they have 3 to 5 kind of services? Does that mean it's time to adopt a Kubernetes? And then they have to deal with these insecure defaults or secure defaults, the network separation, segmentation. And then even there, that you were also talking about attacks. We haven't seen at least a major public or a slew of public attacks, but there's also just the basic AppSec, SSRF, RCE that DevOps teams have to worry about. So it sounds like there is quite a bit that makes it hard, perhaps, I suppose Kubernetes is easy to adopt, but harder perhaps to secure and keep wrangled. Maybe that's the fairer way to put it.
I would say that's fair. I mean, I like to say it's analogous to a vSphere, VMware vSphere infrastructure. Think of all the concerns that you have to think of if you're running your own vSphere cluster. You have to have all the metal, the networking, the storage, the compute, the
How am I
RAM,
going to pay for
disk, and you have to take all that, all that consideration in terms of security, and you have to do all those same things just in a containerized way with Kubernetes. It covers almost all those areas. So sometimes you have to think about it like, remember, we're consolidating a lot of these concerns into one thing, and we're saying, oh my goodness, it does so much and it has so many things we have to secure, but you would have to have done a lot of those tasks anyway. Just in different teams would typically be separated. The storage team, you have the compute team, you have the network team. Now it falls onto shared roles, so it feels like it's more for one person. But just understanding what it's trying to accomplish and standardize across all those interfaces, it is consolidating all those to single standard way of doing a lot of those things. And I think that also has benefit once you understand how that works, and the teams that support all those things understand their share of it, and then they can work together. So I just sort of not trying to put too much down on Kubernetes, but it is solving a huge set of problems, and it does take a lot of diverse backgrounds of expertise to really do it well at scale.
Well, we've definitely appreciated you bringing your expertise to this. And for as often as you've talked about all the minor releases, you've given us some major insights into approaching Kubernetes, as well as different ways of thinking about what the defaults are, what the configurations can do. And we have consolidated quite a bit of it into Matt's favorite line, don't give up root. But Brad, I want to thank you for everything that you've offered, you've shared with us.
Thanks so much for having me. It's been a real pleasure.
Also want to thank Matt and John again, and want to thank all of you for listening. We're going to take a quick break, and then we're going to talk about news of the week.